unlocking data, insights beyond the bits.
The starting point is kind of looking at the the research, and there have been, like, over the past year or so, some very good research that has spoken about why people are going, like, to fail when they are adopting generative AI. This was, like, last year in July, saying that 30% of all of the generative AI projects will be abandoned by the end of the year. Later on, they came and say that the number of projects, and this was in March of this year, that the number of AI projects failing had increased year to year. And the previous speaker mentioned this, was the 95% of projects that didn't provide the return on investment. What they don't really say is that some of them were successful, but really that the minimal value that they were giving to the customers was not there. Well, we alluded earlier, like, to some of the issues and why, but I think, like, the main one is really, like, the undefined business problem. A lot of companies have the fear of missing out on AI and have pushed themselves to apply AI regardless of what they apply it for. So they sing technology and they try to retrofit it to whatever problem is in their company. Poor data quality, we mentioned frog in, frog out, or rubbish in, rubbish out. A lot of companies spent the past few years working on data warehouse. That was a big thing in 2018. They were investing a lot of money, but the problem is that they didn't have a problem that they were trying to solve. So they did all of this infrastructure, all of this organization of the data, but in the end, because they didn't have that project in mind or the use case in mind, that data is completely useless, and you have to restart from scratch in a lot of cases. Limited AI literacy. I think, like, this one is a big one. A lot of people are using AI today to mean generative AI, but they don't understand the limitations of it. Like, I remember a few months ago, I was developing an application that was going to write blocks for me. And I used some of the models, and the idea was to provide, as a parameters, a number of words that I wanted the block to be in length. Well, I wrote my prompt. I passed my prompt to the LLM to check that it was actually a good prompt, because I like to rate and get feedback from my LLM on the prompt that I write. And I got to a point where I got 10 out of 10 all the time, and I couldn't do anything else. And the problem was that it was never recognizing accurately the number of words. Well, I did some digging, and actually Jim and I, at the time, didn't have any notion of words. It didn't have any notion of counting words because it had never been trained. It was never, like, a task that it had been trained to do. So it was always giving me, like, the same length because it didn't have that understanding. And that's one of the limitations. I'm sure everyone has heard of hallucination. Some use the term confabulation. I just say it's a feature. Because at the end of the day, these LLMs or large language models have been designed to please you, to return an answer. They don't care. They don't have anything to prove, to check factuality of the statements. They just will be trained in the way that they are, and they will do what they are trained to. We kind of covered that, like, in the previous presentation, but the pilot to production chasm is generally a big problem because when we do a pilot, we tend, like, to look at a problem in a very narrow lens. We look at a very specific data, we look at very specific problem space, and when we try to bring to production, you are encountering a lot of issues that you didn't plan before. I think the example of the insurer is a very good one because they didn't realize that people were going, like, to provide their ID card. Well, I used to work for a publisher, and we did a chatbot for software support, and it was a tax software. What did we find? That people were passing on the social security number. So we had like to do something very similar. We had like to anonymize, go and look, identify what a social security number looked like, and make sure that when we were capturing the logs and the information, that all of that was cleaned up. So how can we address some of this problem in a way that will ensure successful delivery of products? Well, the first one is leveraging the jobs to be done framework. The jobs to be done for these that are in product is really there to try like to learn what is the problem and what is the people are doing every day. So it goes, when I do something, I want to achieve something, and I have an expected outcome. So let's imagine I'm a newspaper or a journalist. Well, when I write a story, well, I want like to aggregate content and provide information to my readers so that, well, they are engaged, so that they are happy with what they are reading, or that they have the information that they're looking for. So that's a very simple way of thinking about like that framework. And once you really understand what your customer or your client or the user is doing, you can really identify what the pain points were. I was working on a project recently, and the idea was, this was another publishing company, they were aggregating data from a lot of different places. And what they wanted like to identify what was relevant to their customers. And we started looking at the whole end-to-end pipeline. And then what we really found is that one of the steps in the pipeline was really the one that was their pain point. But we only could get there by understanding the full process end-to-end of what they were doing, and then kind of like narrowing down to what was going to provide them with the most business value or the most return on investment. You always want like to start with a customer. But not all customers are equal. Some customers are innovators. Some people are laggards. What is the difference between the one and the other? Well, one is more willing to try new things. The other one is stuck in their ways. When you are engaging with your customer in a practical way, you always want like to look to these innovators and early adopters, the people that are going to be willing to give you feedback very quickly. People that are going like to be willing to try new solution and new ways of doing things that they may have done all their life. There are a lot of different tools that can also help with understanding what they are saying. I like the empathy map because it helps you with separating what has been said from what they actually feel. I remember early in my career when I was still in academia, we used to do interviews with doctors. And one of the things that we were working on was on defining the rules to identify asthma in children. So we sat down with a doctor, and we started like looking at the problem. It started telling us, oh, I look at this factor or feature if we speak about machine learning. I look at that one. But then when we actually look at them and the way that they were processing the information in the live, they were doing a totally different process. They were not capturing all of that piece of information. Their logic was completely different. So if you just listen to what they're saying, they may mislead you because you have not seen what they were actually doing and you were not capturing what they were actually feeling. So this is a way like to help you not going down the rabbit hole of developing a solution for a problem that may have been the wrong problem because you misinterpreted the feedback or the input from the actual customer or from the client. So now we have a problem. We know what we're trying like to solve. We're going like through the second step, which is really the design. What I would say is, whenever you do a design or a new solution, always start by prototyping. provide something that someone can look at and provide feedback on the look and feel. Make it as actionable as you can. Even if it's just a link, like in Figma or some other tool that you're using, having that kind of actionable will make sure that you understand the process and whether it matches what people are doing. Most importantly, check your assumption. As a human, we tend to take information, we tend to map things to our own experience. The problem is that our experience may not be the same as the customer that we're working for. You may have had similar problem, like when I was doing my PhD, I was doing research. I was spending my time looking at academic papers and that type of things. Well, it gives me some idea of what a doctor may be doing when it reviews medical research. But I may make the wrong assumption because the way that I'm looking at the information to find what I need is maybe not the way that they are filtering the information. What is important to me as a computer scientist may not be relevant to a doctor, and inversely. So it's always important to verify and make sure that if you have something that is unsure, ask a question, ask why. There is a very good talk, TED Talk, The Power of Why. I would totally recommend to look at it. I can't remember the author, but it's quite famous. But it's really to solve this problem of the assumption and looking at a problem. And again, you go down the path of creating a solution, but you realize that very early on you made the wrong assumption in terms of the problem or in terms of the solution that you would need to apply. Now, the previous presenter went much higher level, and I'm not going to go through everything, but I think it's important when we speak about AI literacy as well, to really understand that when we speak about AI, there are multiple forms of AI. We must mention deterministic. I like to make the separation between symbolic AI. This was the first form of AI in the 70s, the 50s. It's rule-based, decision tree you may have heard, and it was very deterministic. It's if then else, and then you get a solution. The problem with that is if you don't know what the problem you're looking at, or you get new data, well, the system was failing because it was not adaptable. Now, on the other hand, it was very explainable because you knew that if the rule was triggered, well, that was the reason why it was. Then came machine learning, and machine learning was really there to solve that problem of the predictability or the adaptability. And now we were able to look at things that may not have been seen before. So you could create patterns and recognize from the patterns things in the data, in the input data that meant that it was similar to other data. Now, we still have some level of explainability at this point, but it's harder. Now you get to the deep learning, which is really the basis of generative AI or neural networks. And there you get to the problem where it becomes totally a black box. The reason is that it's doing a lot of iteration. It looks at the problem, it looks at the data, it goes to the next set of neurons, and it will rematch the data. If you try to train a neural learning or a deep learning model, you will see one day you use the same data, same parameters, same feature. Day one you have one result, next day you will have slightly different. Your precision and recall is never going to be the same. What was working well one day is not working well the next day, and inversely what was not working well is working well. Now, one thing that I will say is that what we see as being successful in practice is adopting what we call neurosymbolic AI, which is a combination of all of these different types of AIs. As I mentioned, machine learning is great for adaptability. A problem with machine learning is that it's statistical. If what we're dealing, and especially when you're dealing with text, is exceptions. If you train or you give to your model training data that includes exceptions, then it's going to learn patterns that are unwanted or not really matching what is existing. Now, you train your model with what is the actual expected behavior, and you use a rule-based system or symbolic AI system to deal with the exception. Well, you can get close to 99%, maybe 100%. If you just use the machine learning and you put like these exceptions, you are very quickly going to see degradation in your model. So we spoke about experimentation in the previous talk. One of the things that we did is we took the business canvas and we adapted it for experimentation. So you see, like, there's different aspects. We have the job to be done, to link it back to what we want our customer to do, or what is a problem that we're trying to solve. The type of experiment that we want to do to validate what we're going to do. The part that is very important as part of this is really the data. It is making sure that you're documenting all of the data that is available, the location, where it comes from, what department, what provenance, lineage, and all of that kind of things. But then you have your hypothesis and fail conditions. You don't want to do like as the previous presenter said, data scientists are scientists. They would be happy like to do the same training, the model over and over and over again for life, even if it's not going like to work. Because as researchers, we try to find solutions to problems. And sometimes a problem becomes our life. And that's the only thing that we can think of. Well, in business, you can't afford that. You know, you are going like to have someone else that is going to beat you to it. Someone is going like to do something faster. Someone is going to do something differently and going like to do it better. So you always want the fail conditions and the time box. The fail condition enable you to determine even before the time of the time box whether or not it's worth continuing, and the time box like gives you, this is a point at which if I don't get something new, either I have a good enough model, which could be, or the model is totally wrong, the data was wrong, and I need to think about the problem in a different way. We touched on this, and unfortunately, I know where that is. I like to think about like responsible AI and the principles. And it's important to think about it as part of the design phase. So we mentioned security first, safety first. When it comes to AI, there's other parameters like fairness, treat all individuals in the same way, make sure that you have representation across all of the demographics. So if you train a model to determine diseases across a population and you have different ethnicity as part of your solution, make sure that your data set is balanced. Otherwise, you're going like to have interpretation that are not going like to be good. Transparency and explainability. Always make sure that you have clear explanation, that you document what your model is doing, what data you're using, and all of that kind of things. Accountability, ensuring that the decision and the outcomes are tracked, evaluated, and addressed. Privacy and security, we kind of mentioned, reliability and safety, and the big one. Everyone has heard of human in the loop. I'm sure. I don't like the human in the loop. The human in the loop says that anyone can do the job. That's not true. Experts in the loop. You are trying like to replace or use the thinking that an expert has and translate that into a model that is repeatable and applicable. So how can we solve some of these problems? Well, first of all, when you're dealing with fairness, you want to not only have a diverse team in terms of roles. So if you see here, we have DevOps, UX researchers, data engineer, data scientists, but you also want like the demographics to be different or diverse. especially in the US. In other countries, it may not be, as demanded, but in the US, you really need to have that diversity because it gives you a different perspective. It enables you to think about the problem in a different way and identify potential bias that a male, white, in his 40s would not think about because, well, I don't experience the same thing as people from other ethnicity, women. I'm, a white male. So you want to be challenged, and you want to be challenged by having people in your team that can challenge you and can think about it. And I put back the expert in the loop. The subject matter expert is core to you being able to be successful. Well, when it comes to transparency, and one of the solutions that you have is using a model card. This was introduced, like this one, for example, by Google back in 2018. Hugging Face, if you're familiar with that platform, for every model, you can define your own model card. This is really the starting point, is where you're saying, what do I intend to do? What is the data that I used? What did I do to that data in terms of cleansing it and all of that kind of thing, so that anyone that wants to have any understanding of what is happening can do that. Now, if we think about generative AI, the last time we had a model card for some of the main models was with GPT 2.5, where OpenAI actually provided very clear information about where the data come from, how they were doing it, and so forth. That has not happened in a long time for GPT, and if you look at models like Llama, even though it's open source in terms of the inference, we know nothing about the data, about the process that they're behind. Same with Gemma from Google, and so forth. There are 3 models that I'm aware of for which we know everything about. One is Olmo from the Allen Institute, and then 2 are more recent and in Europe. One is Apertus by the Swiss government, and the other one is OpenHilder, which is another European project. And there they have provided all of the information about what the data was, what the weight were for each of the features, and so forth. Yeah, the other one is really making sure that for the accountability that you track and you log and everything that is going on, why a decision was taken, what were the steps, and that type of things. So we have a problem, we've designed a solution, time to implement it. Well, the first thing that I would recommend is really look at what is called the minimum viable product. And why is it called minimal viable product? It's minimal because it focuses on the essential features that is needed for your customer to be able to test the application. It's viable because you could actually get money from it. You could actually sell it. There is all the capabilities that are needed for it to be a product. And product because it's a working solution. So now you have something that you can actually put in the hand of someone that they can play with, that can provide you feedback. I'm not covering this here, but when it comes to the go-to-market strategy, you have different ways that you can go about it. You can give it for free for your innovators and early adopters so that they give you feedback. You can make it a paid model, or you can have the alpha, the beta, as Ron is doing, and that type of things. One of the things that always help with defining what should go into an MVP is this impact effort matrix. So you always want to look at it from the perspective, what is the effort that I'm going to do to implement a feature, and the impact that it's going to give to my customer. If you are up here, and just forget about it. It's not MVP, and it's probably never going to be implemented in your product. Unless the technology changes and gets better, but otherwise, just forget about it. Where you want to be is really here, where you have a low effort but high impact, or here, but you know that it's going to be a major project. Now, that major project could be your main differentiator to your competitors. So you always have to balance it. You have like to make sure that you understand the market in which you operate to be able to determine whether or not you are spending the money wisely. And here, if your developers are bored and they have nothing to do like during the holidays, maybe you want to give them some of that, or if something is really needed, but but otherwise you kind of forget that as well in practice. What is important is that you need to evaluate these things continuously. So it's not because you are in the implementation phase that you should not have an alpha on the first months or use a sprint method where you ship something, someone starts using it, they give you feedback, but you also want to monitor. The previous presenter, sorry, I don't want to butcher your name, spoke a lot about the evaluation and the agile process. And she spoke about it, like the model testing and all of that kind of things. But you also want like to evaluate and track the user behavior. How are they interacting with my application? Are they happy with it? Are they doing what we are expecting them? And that will help you like to refine the model. So we have an MVP. Well, we have a problem. We have designed the solution. We have an MVP. Now we go like for the other part, which is the evaluate. Why do I say it's the other part? It's because at the end of the day, you have a North Star. And your North Star, you can use OKRs, to like different metrics to be able like to track that you're going in the right direction. Is the feedback that you're getting from your customer going with what your expectations were? Or do you get something different? You have KPIs as well. You have key performance indicators. Here, like I was looking at an idea of a news website that gives information, reduce stress, make sure that the information is trustworthy. So we have a trustworthy score. And we want like to track over time, how is that performing? We have a stress index that you want to monitor as well, like because that was core to the metrics that you said that would be given back return. And then you have your total consumption, time of engagement, and potentially the channel. Because that helps you as well to determine, well, do I need like to spend more? Here we have 35% of our users are using YouTube. Well, probably we should create more content that goes to YouTube, as opposed like to go like to TikTok or that company's website because they are maybe not using that as much or that feature, or that's not the way that your actual demographic is using your application. You may have thought that they were going like to use all of these channels in the same way, but in practice you're seeing from the data that they're only using one more than the others. Which leads to persevere or pivot. Like I'm European, from Belgium. We speak about our failure as much as our success. I've been here in the US for 10 years now, and all I hear is about success. It's very rare that someone really speaks about their failure. The problem is that what that leads sometimes to is people persevering beyond the point at which they should, because they know that they're going to fail. They have all the data that shows them that they are going to fail or that they fail, but they continue going on. So they put more money at the problem, and then you get to a point where, well, the company has to be disbanded or other things because you didn't really look at the data in the right way. Like in the example with YouTube, the pivot is maybe why I abandoned TikTok, I abandoned the website and more natural language content, and I focus on generating videos. That's a pivot. That's how you learn from the data on how you are going like to do. If anything from my talk you remember is when you develop a product, nobody is looking for AI. I've never heard a customer telling me, I want AI. They've always told me, I have a problem. Help me solve it. How you do it, it's up to you. Use the latest technology, use the old technology, make it efficient, but make it that you are solving the problem that I have. Don't think technology first.
Unlock the